Привет, Максим.
We are waiting the hosts. I don't see the hosts. Igor and Katya.
Да.
Are you okay being in the sun?
No problem. Jewish tent. Okay. I don't see Igor.
No, there are several people who are coming.
Very soon.
No one.
I will show some, very few.
I'm sorry, guys, who needs water? It's there. Заработал.
I can't
Very
see.
few
And
pictures.
he talked himself down there.
Can you see?
Yeah.
In principle, I will also. It is possible to show slides in this environment. So. Okay. Good afternoon, everybody. Thanks for coming. First of all, I want to thank the organizers and the people who run this fantastic park, Katya and Igor.
And who created it.
So this is attempt to add to this art environment also some science, popular science, of course. And we hope we will continue this series of lectures, but at least first lecture definitely happens. It is already good. And again, I really thank everybody for coming, expressing support for this. So let me start with the subject. Everybody knows that we witness a real revolution in our understanding the nature of living things and in general, and the nature of humans in particular. And this is due to the development which started in 1953 with discovery of the DNA double helix. And since that time we know that the blueprint of any living organism is consists of sequence of nucleotides or bases, chemical compounds, which are of 4 types: A, T, G, and C, and it is 4-letter alphabet on which the everything about the organism is written. In case of humans, this text consists of 3 billion letters. So it is 3 billion letter text which is confined in cell nucleus of every cell in all of us. Actually, in every cell of our body, it is not 3 billion but 6 billion, because we have in our body cells, which called somatic cells technically, we have double set of genetic information. So all our body cells are so-called diploid cells, so they can contain 2 texts. One text we got from our mother, and the other text we got from our father. And you, of course, know that this text is subdivided into very long text is subdivided into haploid, one set of this text, 3 billion long, is subdivided in 23, if you like, books, chromosomes. And among these 23 chromosomes, there are 1 sex chromosome, and the other 22 chromosomes, non-sex chromosomes. They also are called autosomes. So we have in single text 23. Each chromosome is 1 DNA molecule, 1 non-divided DNA molecule. So we have in our this text, we have in the form 23 DNA molecules, which are enter to chromosomes. Chromosome is half DNA, half just proteins, which compacted technical proteins, not important for genetic information. The genetic information is always written in form of DNA text. What is protein? Protein is protein molecule, as everybody knows, is working molecules in the body. They are enzymes, they are proteins which form all kind of structures, and they consist of different chemicals which are called amino acids. So if DNA is polymeric molecule consisting of nucleotides, protein is polymeric molecule consists of amino acids. Proteins are much shorter than DNA. It consists of much less monomeric units, thousands, not millions or billions. And proteins perform all functions. So essentially what happens during development of each organism and during the life of each organism is that this information, which is stored in form of DNA, is transmitted in the form of protein, which is protein expression, it is often called. So these proteins, the pieces of DNA on which one protein sequence is written, are called the genes. So genes are pieces of DNA, according to modern genetics, is piece of DNA corresponding to one protein. We have about 20,000 different genes coding proteins, and which is actually a remarkably small number. Before first human genome was read, scientists assumed that human had about 100,000 genes. It proved to be much less than that. But this protein coding parts of genome, so this this 3 billion text is called the genome. It is our genome, and the protein coding regions or genes, real genes in genome, constitute a tiny portion of genome, only about 2%. Most of genome is sort of junk. It's sort of junk. It is junk in the same sense as our. Each of you have a personal computer, and this personal computer, over the years, when you had, hard drive of your personal computer, you got it from like around 40 years ago. First time we had started having personal computer, and when we change computer, we carry over entire what is written on our hard drive, on next hard drive, next hard drive, next hard drive. And eventually, if you think about this, your hard drive is full of junk, full of text, full of messages, full of some pictures, everything you don't need, you don't use. But you don't clean hard drive every time you buy new personal computer, because first it is too time and labor consuming, and second, you never know which text or message you will need later on returning back. Exactly the same happens with genome. But only our experience with personal computer goes back to about 40 years. Our genome goes back to 3.5 billion years when life started. And our genome carries these forgotten messages from very, very far below and recent. So all this is somehow written in our, of course, many is lost. Like, for instance, if you go in your computer to some messages which were written and never read again, like 30 years ago, I bet it will be corrupted. So the same happens with genetic information. These messages, very old messages, they are corrupted. Some of them are lost, but many of them are there. And because of this, we now have many labs over the world which try to figure out, to understand what is written in this junk part of genomes, not responsible for any longer for any genes, and because it carry information about our past, about past of our predecessors, about the past. And so now we have fantastic collaboration between traditional science, which branches of science which study the past, like anthropology and whatever, and the genomics, which gives totally new dimension to this our knowledge. And this produce fantastic, absolutely fantastic new understanding what happened in the past. And this is what this aspect of genomics I want to talk about today. Not because genomics has all kinds of aspects. First of all, what kind of diseases may happen with us, what kind of health problems, personalized medicine, so forth and so forth. But it is not what we were talking today about. We're talking today about genetic diseases in the sense of not disease itself and how to deal with it, but when it's how it appeared, how it happened, and what effect it produces on the groups which carry this specific genetic diseases. So this is what, especially in context of Jews, and I will explain why Jews are special in this respect from genetic viewpoint, from scientific viewpoint. But before talking about this, let me again say a little bit about how we get here with respect of knowledge of so many genomes. Now we know in full genomes of thousands and thousands and thousands of people. But first genome, human genome, was read by year 2000, and it happened because of discovery of double helix. Then in by Watson and Crick, and by mid 1970s, the great, now late British chemist Frederick Sanger invented method to read DNA text. It was groundbreaking development. And because of this, by year 2000, after enormous efforts of scientists all over the world, especially American scientists, the first human genome was read, and it cost American taxpayers $3 billion. So $1 for each nucleotide. If the price remains the same, we couldn't go nowhere, because who can afford this? And after year 2000, absolutely fantastic development in technology started, with the focus on making the sequencing of DNA cheaper and cheaper. And now it costs $1,000 approximately. So it was a million times less expensive than original human genome. And now it is, of course, affordable to sequence genomes for everybody, for medical purposes, for research purposes, for whatever purposes. And because of this, we now have this real development of understanding how genomics allow us to understand the origin of ethnic groups, origin of different features. So when we started studying this, then original, by that time, of course, it was already existed for a century, genetics, classical genetics which did not understand molecular basis for genes, but it understood genes empirically and studied genes experimentally. It was started, as everybody knows, by Gregor Mendel in mid 19th century, but his work was completely ignored. And in 1900, several scientists, Hugo de Vries, Horens, and some others, rediscovered Mendel heredity laws. And so genetics started. So the word genetics and gene was coined in the very beginning of 20th century. And the population genetics started, where people, scientists, try to understand the origin of species on genetic ground and origin of different ethnic groups. And of course it was all based on another great work of 19th century, at the same time when Mendel essentially worked. Charles Darwin put forward his theory of evolution, and his theory of evolution is based when it was combined with genetics. It is very simple. So genetics gives you variability, mutation make different genes. Because of mutation, different genes are produced. So species carry different, individuals carry different genes, and when conditions change, all die except those who fit the new reality. So the genetic gives variability. Evolution theory explains that only the fittest survive. So essentially survival of the fittest. And when these ideas in the before molecular genetics, before we understood DNA as basis of genetics, the explanation for different prevalence of different genes among different ethnic groups was based on these ideas of variability and survival of the fittest. And the most brilliant example of this is the sickle cell anemia. It is disease which mostly Africans in northern Africa they have it, and consequently the African Americans from this area. And this is just one nucleotide substitution in the gene of protein hemoglobin. Everybody knows hemoglobin carries oxygen in the blood, and when this mutation happens, hemoglobin becomes defected and it cannot carry oxygen. So when this gene comes from only from one of the parents, so when you remember that in our somatic cells we have two sets of chromosomes, and when it comes from only one of the parents, this bad gene, it does not produce any disease. Moreover, it appeared that in this, oh my God, like this. I mean, so it appeared that in this situation, when a person has one gene good and one gene bad, it is called heterozygous situation. Then the person carrier of this bad gene only in one of two chromosomes has some less afflicted by malaria. So in malaria regions, it is favorable from, in the purely Darwinian sense, it is favorable to have bad gene in one of two chromosomes. If there are in both chromosomes, then person just die, because you cannot live without good hemoglobin molecule. It is impossible. So, but this the death of homozygous carriers, which become sick of this sickle cell anemia, is a good price for population in general to pay for protection of heterozygous, because it is much more heterozygous than homozygous, and it is a good price to pay from population viewpoint to protect against malaria. And if you look at the area of malaria and area of sickle cell disease, they coincide because it is favorable in heterozygous situation, and that's why it was fantastic example of the application of simple Darwinian ideas to genetic diseases, and the explanation why in some populations some genes are prevailing. And for decades it dominated the population genetic field and understanding of diseases and features, different features of different ethnic groups. But it appeared that it was just wrong conclusion. That one example which proved to be correctly interpreted as Darwinian was considered as general. As scientists and everybody always, we have this bad habit to generalize on the very small example, generalize for the entire field. And now we know that it was exception, that such situation when the genetic feature is due to the Darwinian evolution explanation is exception, not the rule. And this understanding came mostly by the studying of a genetic feature of the Jews. Why? That's why this is very important for generally this study of Jewish genetics is very important generally for wind was not Maria. Why don't you just stay and the new idea which emerged from this study of other genetic, especially again Jewish genetic diseases, was it's called founder effect. It is very simple concept. So imagine then you have large population and it has different genetic individuals have different genetic features, which now is here illustrated by two types of red and blue squares. And red and blue squares differ from some gene. And imagine now that by some reason part of this big population departed from the large population to inhabitant island because they, for instance, they are persecuted because they started believing in some different god. They are persecuted for this, and they just escaping persecution. They travel to inhabitant island, and there they established their own community. And when they do this, when they start believing in some god, it has no correlation, of course, with their presence of this particular gene. So this group of people, accidentally, because it's a very small group of people, it may happen to be all red or all blue or some proportion of red and blue, specific proportion of red and blue, because it is small, very small. You cannot do it when you take large portion, because the law of large numbers do not give you any significant deviation from average. But when you take very small number, then it is possible. And these people in this island start multiplying, and this proportion of gene, their genetic lineup remains the same. So the proportion of the specific gene remains the same because they just made randomly. And this mutation does not have any effect on survival. So it is purely accidental. In this new population of people which now form new ethnic groups eventually, that this specific proportion of specific gene is presented. So this is very simple. It is founder effect, and these people are founders of who traveled. They are founders of new ethnic group, and this is all very clear and simple. One example of this this closed population is not necessary. This closed population not necessarily must go somewhere far. Sometimes it happens, definitely, but it's not necessary. It is required only that they, for some reason, stopped mating with surrounding population. You can take small group, and it stopped mating with surrounding population, and then, if it is very small group, some proportion of specific genes appeared, and it will continue to be so because they mate only with each other. They do not mate with surrounding. It is the same founder effect. And a very old example of this is European royalty. European royalty was closed caste of people who did not belong essentially any longer to any ethnic group. They were not French, not German, not Russian, not anybody. They were royal. They made only with each other, and it was not like this disgusting happened recently with Prince Harry took some American girl who was actually divorced. It is just unbelievable. It is could not happen 100 years ago. Absolutely impossible.
It's Louis Chuck.
And this royalty formed absolutely isolated part of isolated ethnic groups, if you like, all features of ethnic groups, and they were just like, you know, that in Russian late Russian Tsars, they were not a drop essentially of Russian blood. They were all what mixture of German, British, Danes, whatever. And it was true for other also countries. And it is very interesting how in this most brilliant example of how this founder effect manifests itself in this ethnic group, like one mutation became prevalent in this group as compared with general population, was the hemophilia. Everybody knows about this. I just briefly remind you. Hemophilia gene. This mutation happened in sperm of father of Queen Victoria, who was Edward, Duke of Kent. It is here. So here, squares are males, circles are females, and red is carrier of the hemophilia gene. And we now know for sure that, almost for sure, that this mutation happened because he was old. He was 50 years old when he conceived Queen Victoria. Conceived Queen Victoria, and it is old age to get children, because in males mutations are accumulated during the life, accumulated in sperm, because spermatogenesis happens all life. In females, different story. it doesn't happen. And so he passed his hemophilia genes to Queen Victoria, but this genes is located in X chromosome. You remember that males are XY chromosome and females have XX chromosome. So Victoria had one of her X chromosome carrying hemophilia gene. Hemophilia gene means it is damaged gene of the production of clotting factor, one of clotting factors. And what is remarkable, we now know, although it happens she was born in 1819, we now know absolutely exactly what mutation happened in her gene. What I will not show you. It is a lot of details, but it is, we know it for sure. And so she was a healthy woman because she had only one of two genes wrong in one of two X chromosome, and the other gene was okay, and it was enough for normal clotting of her blood. But when she had many children, and this guy, male, he was sick because male had XY chromosome, and so if it is accidentally he gets from his mother the ill chromosome, he becomes ill. He doesn't produce any good clotting factor. So he somehow, this guy married even and got even children, which is very unusual because normally these male carriers of hemophilia gene die before mating. You see, all of them, all the rest die before mating, including Prince Alexei, son of Nicholas II and heir of the throne of Russian monarchy. And he but these females carried this gene, which could not be identified with them. So when Nicholas II decided to marry, he had no idea that it was a very bad idea to marry this Princess Alex, who carried, this is Princess Alex here, who carried, she was granddaughter of Queen Victoria, and she carried this hemophilia gene. And she first produced 4 daughters, which was totally useless because in Russia at that time, at the beginning of 20th century, it was impossible. It became very very traditional society. And also in the past, they had women as empress like Catherine the Great, but at that time it would not be possible. And so then in 1904, great celebration happened in Russia because the male, the son was born, Prince Alexei. But he got, unfortunately, this hemophilia gene from his mother. And because of this insignificant extent, Great Russian Revolution happened because it was terrible for the family. Any accidental scratch may lead to his, may be fatal. And as you know, this charlatan Rasputin was became very powerful because he claims that he could stop bleeding. And it led, all these events led to complete destruction of the trust of Russians, of all society to the monarchy, and they finished with it. And they finished with the family. So exactly 100 years ago, 10 days from now, it will be 100 years when all Tsar families is, Nicholas, his wife, 4 beautiful daughters, and Alexei were murdered by Bolsheviks. It happened on 17th of July, 1918. And then Bolsheviks tried to hide this terrible crime, and they tried to burn corpses of victims, but they did it by not well, as everything what Bolshevik did, and they after only after fall of Soviet Union, it became possible to search, even to search for remains of Tsar family. And in 1990s, the remains of all except Tsarevich and Anastasia were discovered, and in 2007, remains of Anastasia and Alexei were found. And genetic analysis was done by, actually not from here in Worcester, by a Russian origin geneticist Evgeny Ragaev. He made all identification of the bones. He extracted DNA from bones of these remains, and he found specific mutation, what happened and who had and who did not have. He got that Tsarevich had, of course, and Anastasia. 3 other sisters were not carriers of hemophilia. So we now know everything about this. This is example of how this founder effect manifests itself in very, you see that in this case, because it is a very bad mutation, so it just disappeared. And now we have all these British royals we have here. It is Prince Charles is here, not it's all 3. But we don't have there are no carriers any longer, even among royalty of this gene. It disappeared. But if it were not founder effect, if they were not formed this absolutely unpenetrable group, and for it would disappear, just diluted in one generation, because like if Nicholas II, instead of marrying this Alex, princess of Hesse, he fell in love before marriage with belly dancer Matilda Shishtinsky. If he married her, we had right now absolutely different world. The entire world would be different, because it would not be a great Russian Revolution, not dozens of million people died for nothing, and maybe no Second World War, maybe no First World War, because it was already a bad situation. So it is a fantastic example of power of genetic. One change in 3 billion letters was created all this. And this structure of society allowed it to happen. So now about Jews. So it is clear why royalty formed this close society. But we know that Jews also formed close society for many, many years, also before recently when intermarriage started common. So for centuries and centuries, Jews were separated from surrounding population by religion and the hatred of surrounding population. And this led to the formation of essentially founder situation. And study of Jews is very important because we know a lot about Jews from history, and we still have many Jews, fortunately, survived even after Holocaust. And so it is possible to make very detailed studies on many individuals. And to just make you a little bit fun, to show you that we still have some Jews who remained for, I show you something. So this is the, it is a famous fresco by absolutely right, Piero della Francesca in Arezzo. And here is Queen Sheba visiting him. And here is this right-hand side, they meet. This is Solomon and this is Sheba. And so I show you what my sister Maria made snapshot several years ago of me, like Solomon, and you see that we have remarkable resemblance. The same nose, the same eyes, the same mouth, the same ears, everything is essentially, she's just a little bit younger here than me. So, of course it was not Solomon who was painted by Francesca, but it was a Jew of his time, so it was half a millennium ago, 1470s, and he has absolutely the same features as me. And so we can say that yes, for this long period of time, Jews probably did not, at least for this period of time, last half of millennium, which ended, and before this, before 20th century, because in 20th century situation changed. Jews did not mix with surrounding population, and we still, some representative of Jews have the same genes as our ancestors. And founder effect plays enormously important role in understanding the what happens with Jews genetically, because Jews, as we talked about founder effect, so we need to have small number of individuals for founder effect to manifest itself in food. And this small number may happen when you just isolate small number, or you can isolate small number, but they can multiply, and then it will be no founder effect any longer, because founder effect does not work for large population. But then if something happens and populations shrink by some terrible events, then founder effect manifests itself in food. So among Jews, only Ashkenazi Jews, Sephardim Jews, only Ashkenazi Jews essentially are of interest in this respect, because population of Ashkenazi Jew went through several bottlenecks. Ashkenazi Jew and their direct ancestors. And there are two major population bottlenecks in the history of and prehistory of Ashkenazi Jew. First is destruction of temple in year 70 by Titus, and when this happened, Jews were essentially exterminated. Before this, in just 20 years ago, it was million Jews lived in what is now Israel, and then it left very few, and these very few Jews were probably taken in slavery by Romans. And most probably they eventually infiltrated through Alps to the north, and on the banks of Rhine, these founders founded new population of Jews, Ashkenazi Jews, which speak Yiddish, which have all these features we know about. And then they started multiplying, and by about year 1100, it became like, by some estimate, it's all of course approximate, 150,000. But then, by the middle of 14th century, their populations shrink to about 350 people. It is results of genomic analysis. Genome analysis shows that at this time it only about 350 individuals of Ashkenazi Jews.
Because of it was a year of plague.
Absolutely.
And it was a terrible massacre.
It was because of plague. First of all, it was because of crusades. Crusaders, before going to Middle East, they exercised on local Jews. Then it was Black Death, and Jews actually survived much better during Black Death because they wash hands, and it is critical, as we now know. But because of this, Christians suspected that they were responsible for this curse, and they started just killing them and killing them and killing them. And the result was this almost total extermination of Ashkenazi Jew population. And this was bottlenecks most probably when specific genes start prevailing in Ashkenazi Jews. First of all, Tay-Sachs gene of Tay-Sachs disease, because it is not true for Sephardim Jew, for instance, or for they do not have it. So only Ashkenazi Jew are so different in their genetic makeup from surrounding population.
So before you change posters, what was the middle column?
Okay, don't take it.
Generation.
Yeah, it is middle column. It is number of generation from today. So it was 78 generation before today. Generation is 25 years. It is simple.
Okay, historically speaking, like you take the number, the population number, and connect it with a year, because, and you could explain with the historical events that happened at the time, or you simply take this number that was known at that year.
Actually, it is not my
Because,
table. I just
it's
took
somebody
it
else's, right?
from some scientific paper.
Right.
Who took it from us?
1648 is
So
the
it
end
is.
of
I
30-year
cannot.
war.
Lena, I cannot.
So
defend,
historically, okay.
defend all these numbers. They are. I mean, all these numbers because they are not known for sure.
Right, because what's interesting that in the span of 19 years, you have this difference from 200,000, whoever determined this number, to 116,000.
Yeah, I don't know.
Yeah,
This,
I'm just curious.
I just don't know.
Well, 1648 is a remarkable date, year in the history. It was the year when the 30-year war has ended, right? But why there is a change in the population after
I don't
so
know.
it's interesting, right?
Lena, I
But then-
don't
right.
want to discuss all this
Yeah.
because it will just
No.
distract us. It
Okay.
is not that important.
Right.
One number maybe is important. It is that between here, the end of 18th century
Yeah, well, that's
and
more or less understandable.
it was
later- yeah.
it was huge.
Yeah.
Huge
Explosion.
Explosion.
Yeah.
It is called sometimes
Right.
demographic miracle of Ashkenazi
Napoleonic
Jews.
times and
yes,
things
yes,
like that.
exactly.
Yeah,
it
yeah,
was
well, that's
due to
understandable.
emancipation
Yeah,
by
that's
Napoleon and other good things which
Sorry.
make this fantastic.
Right.
But it is Jewish history. It is not
Okay.
genomic Jewish history.
So you had said that that Tay-Sachs affects Ashkenazi Jews, not Sephardic Jews. And is that correct?
What is it?
Tay-Sachs?
Tay-Sachs. Tay-Sachs disease is absolutely
Only Ashkenazi?
absolutely only Ashkenazi.
And the reason for that is
Reason for that,
environmental?
let me explain. This is a very good question. That imagine that in this bottleneck, when there are only 350 left, accidentally among these 350, the Tay-Sachs gene, which was present in general Jewish population, but in normal, very small, Tay-Sachs gene present everywhere. But among Ashkenazi Jews normally with random mating get ill with Tay-Sachs disease 100 times more probable than any general population. So, but accidentally, like in this so when
Make it clear that this happens in
this
all
when
the population.
Maria, I can give you when this shrink happened accidentally, the individuals carriers of Tay-Sachs disease had just
Was carried by them.
much more than among general population. This accidentally happened.
Yeah, okay.
Tay-Sachs, it is just name. It is two guys who first describe this disease, two doctors. One had named Tay, the other had named Sachs.
What kind of disease is that?
It is neurodegenerative disease, very bad. So normally patient dies like 4 years old, something like that, very early.
So only Ashkenazi Jews
Only
carry
Ashkenazi
it
Jews.
down.
Among Jews. Only Ashkenazi Jews.
Okay, so an Ashkenazi and a Sephardic Jew cannot transmit the Tay-Sachs below to the next generation. Only Ashkenazi.
Yes. You can, if you are Ashkenazi Jew and want to marry Sephardi Jew, you are safe. If you're Ashkenazi Jew and you want to marry Ashkenazi Jew, you need to do genetic test. And this is what is going on right now among Ashkenazi Jews all over the world. They do genetic tests, and normally they do not marry in this situation when both prove to be carriers, because
So it becomes dominant.
probability is 1/4 that your child will be terribly sick. And this is true not only from civilized Jews, but also for religious Jews. They also do this, because they know how terrible it is. They may not do abortion in any case, but they can just, for them to not to marry because they have arranged marriage anyway, not to marry is not big deal. Find another.
Explain that the normal population is also having disease, but the prevalence is
I said 100, I said, Maria, you hear it what I'm saying? 100 times less probable. 100 times less probable. And it is Sephardi Jews the same. So, most probably this happened during this bottleneck. And from this bottleneck, Ashkenazi Jews started being different with their genetic features than Sephardic Jews, and they became even more different from non-Jewish population. So there are other examples. Tay-Sachs disease here, it is written here, so you see how it is spelled. Tay-Sachs. And it is written here some data about this disease. So it is a lethal neurodegenerative disorder. It is autosomal mutation, so it is mutation not in sex chromosome, like in case of hemophilia. It is mutation is autosome, not non-sex chromosome. So it manifests. It is recessive mutation, so it manifests itself only when in 2 chromosomes there is mutation. So that's why carriers are absolutely normal. When carriers, people who have 1 chromosome, mutation in 1 chromosome, they are absolutely normal. And there are every one of 30 Ashkenazi Jews is carrier of Tay-Sachs. It is fact. And so it is some details that it is insertion. So 4 nucleotides, TATC, are inserted into the gene. And this is some gene, whatever, it is on 15 chromosome. We know everything about this. And so after already for many years, this genetic analysis is being done for Ashkenazi Jews. And as a result of this, as people did not marry when they both are carriers, and it is clear why it is necessary to do so, because if you are Jew and if you normally want to have many children, then it is absolutely impossible for you, if you have or both are carriers, not to get 1 child, and 1 child is more than enough for family to be essentially terribly upset. And so people do not marry, and as a result of this, now the occurrence of Tay-Sachs disease among Ashkenazi Jews is lower than in general. So essentially, it went to 0.
That's great.
Yeah, I have a question. I remember years ago, my husband and I were tested because we knew a child who had Tay-Sachs. It was out of Jefferson Hospital in Philadelphia. I think it was a doctor. He had 4 children, and he started a testing program for Jewish people in the community. And he said, oh, no need for me and my wife to be tested because we have 4 normal children. And lo and behold, he was tested. He tested positive. He was a carrier. So was his wife. They just lucked out 4
Yeah.
times.
They were just lucky. It is 1/4 probability, so you may be lucky. Absolutely.
So you feel it went down now because of abortions? People are now tested. They test now. For
This I don't know. This I cannot say. But whether abortion contributed to this one, you mean prenatal diagnostics?
No,
I don't know.
incident.
I don't know. I don't know. I didn't read something about this. I know that most significantly was testing before marriage. Testing before marriage, not prenatal testing. Already when it is, because if it is abortions, then, for instance, for religious people, it is not enough. Abortion is not allowed.
That won't be comes down to the Supreme Court. It's not going to be an option for anybody.
There isn't any religious tradition. So it is most dramatic Jewish gene, Tay-Sachs gene. Another gene is familial hypercholesterolemia, which actually is much wider spread in general population. So Jews have not that much, only 2-5 times higher probability, not 100 times like in case of Tay-Sachs disease, but still it is elevated for Jews. So probably it was also, as many genomicists think, it was the result of founder effect also, but it is less
What is the
pronounced.
disease? What is it?
And probably it happened in the same, approximately the same time. When again, you need to have very small population to founder effect to manifest itself. So there were not that many bottlenecks even in Jewish population. Now, the question we can ask me, obvious question, is whether, but you may already understand the answer, whether the most terrible event in Jewish history, Ashkenazi Jews especially, Holocaust, could affect the composition of genes among Ashkenazi Jews. No, it couldn't, because also in absolute number it was absolutely terrible event, but still millions of Jews survive. And when there are millions, you cannot get founder effect manifested. Absolutely. So Jews remain the same in general after Holocaust as they were before Holocaust. I think I essentially talked what I wanted to talk about, and I answer some questions. I will be glad to answer any other questions.
My only question is, you said it didn't happen as a result of the Holocaust, but could it also be because men and women weren't cohabitating then? They weren't allowed to live together. Men and women in the Holocaust did not live together.
No, I mean after Holocaust. We had Jewish, Ashkenazi Jew population
Yes.
before Holocaust. It was like 14 million Jews, but probably about 10 million Ashkenazi Jews before Holocaust. It was on this picture.
Yeah, I saw.
Yeah. Yeah. So we had, my point is that now, so we had it's not indicated here. We had 4 million in 1900. We had probably, I don't remember, it's known of course, but probably 10 million or 9 million Ashkenazi Jews before the Second World War. And we now have again 10 million. I say that the genetic composition of this population before the war and now is the same.
Okay.
It couldn't change because it is a large number theory. So when you have large numbers, you cannot get any prevalence of any because even if you eliminate half of population, if population is large, the composition, genetic composition remains the same.
Thank you. Thank you.
Yeah.
This feature as a genetic damage gene, so could we use it for investigating where is 12 from 12 Jewish generation 10 lost? So to find from Japan or Ceylon or so, what is it? Does it make sense that this is some sort of tool to clarify Japanese gene?
It is very difficult. One thing I want to tell you in this respect, I cannot answer your question. We can, but I never heard about anybody doing this. What actually very interesting, which I did not mention, and now I can, because I have time, I can say this, and some of you will be upset. So half of you will be upset. Best half. Actually, recent genetic studies show that Ashkenazi Jews are Jewish only by remain Jews only in male part, because we can study genetically the difference between males and females, because only males have Y chromosome. So Y chromosome is transmitted only via males. And we can study so-called mitochondrial DNA. So in addition to genome, chromosome, all this which is within the nucleus, we all have DNA also. DNA molecules in cytoplasm, outside nucleus. They are small molecules, they are located in such small bodies in the cytoplasm, which are called mitochondria. It is mitochondrial DNA. It is only about 15,000 nucleotide long, very, very short as compared to genome. But it is transmitted only from mother. So it is only female transmission. Because spermatozoid does not bring any cytoplasm. It doesn't have cytoplasm, is only in egg cell. And so people started studying what is male, how male heredity transmitted in Ashkenazi Jew and how female. And they found that by studying mitochondrial DNA, that female in which were founders of, it was at some point founders of Ashkenazi Jews. They were males and females were not Jewish. They were probably Italian. So when this, Sarah, we're talking about much later, Ashkenazi Jew. Ashkenazi Jew as a group appeared only about 10th century AD. And probably when these Jews, which were enslaved by Romans, the Romans took them to Europe, northern Europe, over Alps. And of course they took only males. They didn't need females because they needed strong guys. slaves, and they took them, and while they were traveled to Rhine, they pick up as wives local women.
I'm sure that the female Jewish population were sold on the slave markets as well as the male.
Oh, yeah. I'm talking about pure genetic analysis. Any genetic analysis must be, of course, it was one publication, but in very good journal and very solid publication. It was in 5 years ago, in 2013, in Nature Communication. I have this paper, and from a genetic point of view, it is very convincing. Whether it is true or not, but I said some of you will be upset.
Not upset. Thank you. Thank you.
I understand that Cohen, Cohen's Jewish religion, traced through the DNA. Is that?
Yeah, exactly. It is Y, absolutely right. It is Y chromosome.
And
It is done
specific Cohen
No,
chromosome?
it is done via Y chromosome because this ancestry went through men's generation. So they study this by Y chromosome, and they found some differences. Yes.
Excuse me. Sir,
Yeah. Yeah. True.
is the treatment of hypercholesterolemia different for those who are familial type versus those who do not have the genetic typing for high cholesterol? Do they respond differently to the present medications that we're using
Well,
to
I
treat?
cannot answer this question. I am not medical doctors also I myself have problem. Definitely, I got.
States are not related.
Yeah. I think the medication is good for everybody, in my opinion.
Statins are for
Maxim, let me make a small announcement, and then you can continue during the session. First of all, thank you all for coming, and please stay with us, because after this wonderful lecture, we'll have a celebration of Konstantin Simon's exhibition, Faces. We were surrounded by those faces during the lecture. They're behind the amphitheater, and Konstantin Simon by himself was picturesquely lying there among them. So please stay with us. We'll have some drinks, snacks, good time, and Sergei Nirenberg will play his wonderful accordion. We hope so. And so please continue now.
So I also joined this. That I know Konstantin. He is fantastic.
Do you have a reaction to Anatoly Klosat's work?
Oh, I have. Absolutely.
Yeah, in two words.
He is absolute charlatan.
Really?
Absolute 100% charlatan.
That's a strong statement.
Never read his books. It is disgrace. I know him. I know him personally, and I looked at his. I don't know how many books he published in Russian. Maybe 100. He is absolute charlatan. Although he is a good biochemist, but in genetics he is absolute charlatan.
Didn't hear the questions. I don't know who you're talking about.
It was asked about Anatoly Klosat, who published many everywhere about books and everything,
especially in Russia.
but mostly in Russian. And I say he is charlatan. Yeah. Oh, yeah, I'm sorry. Yeah.
I have two questions. One is so basic you can probably just say yes or no. I understand the Sephardic Jews are the ones who were from Spain, and is everybody else Ashkenazi?
No. Of course not. Of course not. There are Spanish Jews. It is Ashkenazi Jews who were expelled in 1492, right? And where it is North Africa and many most Italian Jews are Sephardic, and Greek Jews are Sephardic. But there are also Mizrahi. There are just Jews who left after Babylon captivity in this area in Iran and Iraq and other places. So there are Georgian Jews. There are collectively called Mizrahi, and there were many, but they don't have. Ashkenazi Jews are so interesting because they had this extremely turbulent history with population bottlenecks, not like other Jews. Even Spanish Jews who were expelled, which was terrible, but their population never got to such number like several dozens. They always remained in large. So founder effect, which is most interesting from genetic viewpoint, population genetic viewpoint of what I talked about, founder effect do not applicable to this. So they are not interesting objects from this point of view, like Ashkenazi Jews. Ashkenazi Jews are special.
And so they're all European Jews?
Ashkenazi Jews, nothing is without controversy. Yeah. Everything has several sides. So Ashkenazi Jew nobody knows how Ashkenazi Jew appeared. Nobody knows. We don't have any record, not historical, not genetic, which says Ashkenazi Jew appeared in this approximately, very approximately, on Rhine. But also, there is theory that Ashkenazi Jew came from Hazar. But it is bullshit. It is bullshit. Although there are some genomicists who support this, very few who support this viewpoint and publish papers on this. But in my point of view, it is complete bullshit. That it was because we are not this, right? It is ridiculous. And language is based on German, Yiddish based on German. So it is not.
So then
it was first Arthur Kessler coined this idea because he wanted Jews not to be responsible for Jesus Christ crucifixion. And he said they were not there at that time, Ashkenazi Jew. Ashkenazi, because he was some Hungarian Jew. He said, we were not there. We are Khazars. We are not from Middle East. And but it is ridiculous. Now we know that maybe females are not responsible. Jewish females are not responsible for Jesus Christ. It is more solid. What else?
The other question is, I don't really understand what a genome is. I mean, if people are so different, they have different genes. So what does it mean when the genome of a Homo sapiens is
It is actually, it's a very good question. It's a very good question. It is absolutely a good question. So, of course, when human genome is read, it is read for some specific individual. And first genome was Craig Venter genome. It was some guy who contributed a lot in obtaining, and he just sequenced. He was he headed some company, and this company yes, they competed with NIH, with huge consortium of scientists, and they were privately funded, and he obtained a sequence of his own genome. Then Jim Watson genome was sequenced, and so forth. So each genome, of course, it belongs to some particular individual, but they are extremely similar. almost indistinguishable. So differences between genomes of all us who are small. And in significant part, well, there are different parts of genome. Some parts really vary very quickly from generation to generation. That's why we can do absolutely firmly the parental analysis. But it is not interesting from biological viewpoint. It is just junk. It's complete junk. And it is not interesting. All genes, real genes which code proteins, they are almost the same in all humans, with very small variants. Because if you have even one nucleotide different, you get sickle cell anemia, or you have Tay-Sachs disease, or you have some other terrible thing. So genome is genes, real genes, sequences which code proteins. They are almost the same.
So then they can tell where your ancestry is from, if you're from
For all
Africa.
other, for junk part.
Oh,
So
the junk.
we have only 2% of important part, and 98% of junk, and this junk carries all this information. As I told you, like in our hard drive. In our hard drive, we have only tiny portion right now of messages, papers, pictures which we really care about, right? And we can eliminate all the rest. I don't know numbers, but definitely it is tiny portion. And all the rest is junk. And this junk, if you make some bad thing and you FBI goes to take your hard drive, they will learn everything about your past, everything. Because it is all a junk part of your hard drive.
Question. Can I ask a question, Maxim?
Sure.
Okay, now the DNA analysis test became very popular for the individual.
Yes, yes.
Can we trust the results of those analyses?
I am very skeptical.
Uh-huh.
I am very skeptical. I think that this I don't know. I never studied this. I never looked at this carefully. I think that in any cases when they definitely can say whether you are Jewish or not Jewish, because Jewish genomes are very, very well studied. Especially if you are not French Canadian and you have Tay-Sachs gene, you are Jewish. You are Ashkenazi Jew, almost certainly. But I am afraid they just use this simple thing, which is obvious anyway. I haven't seen a single person who said, "Oh my God, I proved to be Jewish. I never heard about this." He proved to be like 20% Jewish. What does it mean? Well, this percentage are foolish. You are either Jewish or not Jewish, and it is all these quantities are
For
not
those
reliable.
who are half Jewish or non-half Jewish,
You may be half
that
Jewish.
analysis
Yeah.
could be trusted?
Probably.
Could be trusted.
I think everything with respect of Jewishness probably is reliable. Probably, but I am not expert in this.
I heard about a specific gene, like who's caused for breast cancer, like among Jewish, Ashkenazi Jewish. Is
Yes,
it true?
there is. I just
Is
yeah,
it
exactly.
same thing
Yes,
with
but
other
I
diseases?
don't know. I don't have data. I just don't look at this carefully. I don't have data how much this prevalence is like, because in case of this gene hypercholesterolemia, it is only 2-5 times. I am afraid that these numbers for cancer, breast cancer, maybe also this type. It may be small preference, again, due to founder effect, but not that Tay-Sachs disease remains unique because it is so high preference. Other things are small. Okay. If you have 2 times more, what does it mean? It doesn't change anything.
I'm sorry. Is my understand we found out to somebody if you Ashkenazi, you can be prone to a pancreatic cancer. It's very prominent.
I don't know. This I just don't know. Maybe, I don't know. I don't know. Nowadays you have so many such things that it is difficult to follow them. I just don't know. About breast cancer, I read, but about pancreatic, maybe I read but forget. I don't remember.
Was an oncologist.
But again, it is all this correlation, recent correlation, are very small. It doesn't change anything for you because yes, you may have a little bit more because you are Jewish, but you may have more because just you were unlucky. So it is just doesn't change anything. It is not important. These small preferences, not important. So you have a question?
Yeah. Well, it's not a question. I just want to say something concerning the founder's effect. There's a recent book that came out called The Family Gene. I don't know if anybody here has heard of it. It's about a disease, an illness that occurred in a family about 6 generations ago. They happen to be Jewish. And they are the only family in the entire world that came down with this particular disease, which has no name. And it affected, I think it was 9 members of the family or more. And they were able to finally stop it. And part of it was some of the members did not have children. But they've all been tested. This last generation, which is, they're now in their 30s and 40s. And they have stopped it. But it's a very interesting read, and it's an easy read if you're not a scientist. And it's called The Family Gene, and the author is Jocelyn Linder. And they went all the way back many, many generations.
Very interesting. I haven't heard.
Very interesting. Family Gene.
Any other questions?
So regarding to some businesses who is 23.
Yeah, 23
ancestry. So they pronounce that 20% of your legacy is Gypsy, 20% of South Africa. So how precisely that? And how they use? They use mitochondrial DNA. How they found that this from?
No. I don't think they. I don't know. I doubt they use mitochondrial DNA. Probably it is just several. Some pieces, of course, they do not sequence your DNA because it would then be more expensive. They take like $100, right, for this. So they do not sequence your DNA. They just PCR, using PCR, multiply some specific regions they know are indicative of this, and then they make this conclusion. So how it is, how reliable it is, I cannot say. I say again, everything related to Jews is more reliable to other, like gypsies or anybody else, because Jews were studied because of this, Ashkenazi Jews especially, because of this several reasons, they were studied very carefully. I visited a conference in 2016, first conference of Jewish genomics in Haifa. It was huge gathering. So it's many people do it. But rather than that, I don't know. I don't have my own opinion about these companies. They are essentially, it is business. It is not science. So how can you judge about them? they just do their business. It is not publications. They do not go to peer review process. It is not science. But it doesn't mean that they are crooks like this guy. So I really join Katya that is saying that Kostya Simon is absolutely fantastic sculptor. I know him for many years, and he did very, very good art and continues to do so. I really, he's over there. Kostya! So I